was pretty cool, huh? Let's see how we got this far. At Lynbrook Robotics, you have the opportunity to learn how to design and machine a complicated robot. You have the chance to wire motors and solder sensors. You get to write advanced software that makes the robot drive in elaborate paths. Or you can make beautiful graphic designs and animations seen by thousands of people every year. Lastly, robotics is a place where you can have fun.
It begins on an early Saturday morning in January, on kickoff day, when the challenge is announced. The entire team comes together for a party, with lots of food of course, to watch the live stream. After the game is announced, it's time to build. All the magic happens in a 6-week period known as build season. How many of you have experience with Legos? You can take apart and rebuild things within seconds. However, this is not the case with our robot. Many of the parts that we put onto our robot are specifically made for our robot, so taking them apart would be incredibly time-consuming and inefficient. In order to work around this, we 3D model our robot using computer-aided design, or CAD. This allows us to have a model to work off of while machining our robot.
And after the robot is designed, we need to machine it. In our machine shop at Lynbrook, we use 2 mini-mills, a bandsaw, a drawer press, and a lathe, similar to Miller wood shops. The highlights of our shop are the 2 CNC mills, which are giant 7 feet tall programmable mills that machine parts to the nearest thousandths of an inch. Another project is building the wooden game elements on the competition field, which are necessary for testing our robot. It's a great way for you to get started in the team. Software control your robot. We write software that automates control for many aspects of the game, such as moving the elevator to a fixed height or collecting a ball. We also worked on a really cool project we call the line scanner. Similar to a Lego Mindstorms robot, this robot detects a line and moves the top of itself side to side to keep the ball in place. By looking at reflective tape, our robot can even follow a moving target.
We also need to wire up the robot to deliver power from the battery to the motors. To do this, we model the electrical components on a computer to eliminate any problems before the physical robot is done. Then we can wire up the robot neatly and quickly after the building is complete. This is a picture of our robot as it was wired on stop build day.
What we do may sound complicated, but don't worry, no matter your experience level, we've got you covered. In the fall, we hold weekly workshops that teach you about all the different aspects of our team, even beyond building a robot. These include electrical, software, machining, computer-aided design, media, and animation workshops.
The Girls Subsystem Challenge is where girls work together to design a major subsystem. Our subsystem this year was the drivetrain, or the base of the robot, which allows for movement across the field. In the Girls Subsystem, we design everything from shafts to battery boxes, and you create those parts using a wide variety of machines. At the end, we assemble the frame with gearboxes, wheels, and chains. The main point of the challenge is to welcome girls into a comfortable environment while challenging them to go even further. For me, the Girls Subsystem helped me gain confidence in my design skills, and as a sophomore this year, I successfully led and designed our drive gearbox.
After we build a robot, we ship it out to regionals to compete against many teams from all around the world. Every year, we travel out of state for at least one competition. You'll be blown away by the massive scale of the event venue. The bleachers were endlessly filled with thousands of teams. I've met people from China, Australia, and even Turkey. But to do everything that we do, we need money and a team structure. We have students passionate about business and organization as well. We write grants to our company sponsors, document our team initiatives, and engage with our community at various outreach events. We know high school has a lot of cool clubs, and as you transition from middle school, we hope you give yourself the freedom to explore. But we hope some of you find your new home in robotics. Thank you.